So, how do you create artificial general intelligence? Well, with science and invention, you observe something in nature, and then we are able to recreate that to our own advantage somehow. So, we're able to observe that birds can fly, and we can take those observations and we can uh, make airplanes that we can use to fly to our advantage. We can observe that the trees use energy from the sun, and we can make solar panels that collect energy from the sun for our own uses. And all sort of scientific achievement and progress and invention comes from these types of observations. Um, and so, with creating an artificial general intelligence, the observations that um, humans are smart, and so we should be able to recreate that intelligence. So why haven't we been able to do that yet? So uh, the current approaches what happened, like, before computers, we couldn't conceive that it'd be possible to even like replicate human intelligence besides, like, making a baby or whatever. Um, and so that sort of invention wasn't as much on our minds. But then once you have more sophisticated machinery and specifically computers, um, that becomes more of an idea. And so, like, with computers, um, what ends up happening is we make the computers, and we can see that they can compute anything. And so what's happened is we went, okay, well, computers can compute anything, and so we see that uh, like, humans have this consciousness and this intelligence, so then we should be able to compute that on a computer. Um, and we're not wrong for thinking this, but in terms of the approach of how to think about this to actually build this is why this isn't working, because um, we're not actually trying to, like, recreate human intelligence, trying to do some weird thing with this computation, because we know computers can compute anything. And so if we want to and like we see with, like, different approaches, they're all based on how computers work, how computers think about information, and not about how humans and human brains think about information. And there's, like, so in order to approach this, we have to approach it from forgetting how computers work. Like, yes, computers are useful and we can use them in certain parts of it, but go back to thinking about, well, how does the actual human brain work? And um, use that as a starting point for how we're going to create our general intelligence. Okay, so if we're looking at it from the point of view of, well, how does the brain work? First, we have to understand, well, how does the brain even get built in the first place? And so, well, we know that we have DNA, and that the DNA is a set of instructions that says how to build everything in our body. It says how to build the fingers, the hands, the arms, all my organs, everything about me, including my brain. And it it's gotten the current design from that it has through evolution over billions of years of trial and error. Um, and and so if you think about the brain, how it actually ends up developing, um, just like how we have, there's instructions in the DNA to say that I have 5 fingers and they're placed this way on my hand and whatnot. Similarly, in the brain, there's DNA that says, well, you have a structure for processing sound, and it's structured like this. And you have a structure for processing vision, and it's structured like this. You have a structure for thinking about language and moving your mouth to speak, and it's structured like this. And so the DNA provides sort of a basic, high level sort of instructions for how to build these different components that are in everyone's brain. Um, and we know everyone's brain has similar structures from brain scans and whatnot, and also from the fact that the DNA, all of our DNA is so similar, and the amount that's different can, of course, make everyone's brains a little different, but overall they're generally set up the same way. Um, so so what's cool is that nature's created this DNA instruction set over all of these different iterations, um, and gives instructions how to build these different structures. Now, these structures, it's like they're made out of neurons, but I don't think I would classify them as neural networks because, everyone has the same sort of basic experience, and so our it's not like our neurons have just sort of um, by chance wired themselves together to give everyone the same experience. Our neurons have, through these structures, given us the same experience because we process audio the same way, because we process the vision the same way, and and all of these other things. Um, and so so the way that nature's learned how to do this is through evolution, but we have ways to do this through computer programming and coming up with ways to process audio, to process vision, to synthesize speech and do different things like this. And so, in creating a general intelligence, the big problem isn't neural networks. The the problem is software. You need to have all of the algorithms, basically. You need to be able to um, have all of these different ways we know for how to process information, and our brains have built these structures through evolution, learning that way to build them, but we can build them through software by through our own techniques through learning and whatnot. And so the tricky part is gluing them all together, and that's where neural networks can come in handy. But you can't just take like a bunch of virtual neurons, so to speak, and just have them assemble into something intelligent, because that's not what nature did. Nature has created, it basically programmed the brain, and code is in the DNA, and how like the protein and everything builds the DNA into your body. Um, so that's the challenge. The challenge, which is really interesting. So the way AI is talked about is that the challenge with it is big data. You need lots of data and you need lots of computation. But like I have with my intelligence, it fits inside this amount of space and it can do all of these amazing computations. And so needing a whole bunch of CPUs isn't really true, right? You don't, because like this is the solution. It's right here. We know how much power it needs. It doesn't need a huge amount of power either. It's like the amount of like a light bulb, an LED light bulb, a couple of them maybe. And you don't need like much data because like all the structures are baked in through they're pre-programmed, and so all of these different preconceived notions we have about AI and how to build them, I think, are all wrong. So the most important thing is to be able to assemble all of the software, and so this means that this is something that can't be developed in private or have any secrecy around it. It's something that you have to logistically build in public because you need the entire world's knowledge to be able to assemble it into a cohesive system. So what would a system like that look like? So we already have uh, something like this already. It's called the internet, but it's just not organized or connected in the ways that we want it to or need to. And so we have like Google would be sort of like a prototype version of this, where you go to Google and you type in your query, you get your result, and you go to the thing. But instead of doing that with just information, you can do that with software. And so you go to this AI, this thing, and you instead of doing a search term, you give it a computation that you're trying to do. And what it's able to do is uh, like Google does, where it looks through the entire internet and it knows, like if I look on Google for um, cat information, then it knows like the best piece of information or best place to go for information about cats. You could train this system to know when I say like, okay, I want to, I've collected this data and I want to make it look, have show it in a nice graph. Then you tell it you want it to do that computation, and it knows the best piece of software to do that with, and it knows the best settings to do that with, and because it's learned this from everyone else using this system and training this system to do that. And um, through this, you could better organize the world's not just information, but also like our technical know-how and whatnot. And um, I think this is so much more important than focusing on language models, because if you're making a general purpose AI, you don't want it to be an expert in language. That's the last thing you need it to be an expert in. You want it to be an expert in math, logic, science, computer science. Because if it's an expert in those fields and it knows how to do any computation, then you can just tell it, okay, well, understand language, and it can just compute that. We don't have to figure out how to do that, because it's so good at computing that it can compute that for us. And likewise, you can figure out anything. It can figure out how to do any task that you want. So well, this system also has problems. So so you could make a system that's extremely intelligent, be able to do all these different kinds of computations. Um, but it wouldn't be able to drive a car. You could compute anything as long as you're willing to wait a little bit of time for it to think about it. But when it comes to the problem of driving a car, a general purpose AI in this manner can't do that, because because of how computers work, and how you have to program a system like that to work. You can't get it to run fast enough. Even if you try to make the hardware and overclock it and make the processor go super fast and try to make it, we'll run it on like 1,000 different cores and whatnot, and try to speed it up. You're never going to be able to um, to do a task like drive a car. And so why is this? Well, okay. So the problem is that computers compute things in steps. And if you look at how the brain works, that the brain doesn't compute things in steps. It just sort of computes it all at once. Um, and that's why we're able to do things like drive a car. So this is pretty interesting. So like, yeah, the way a computer works is in steps. So works a lot like if you were adding two numbers together, right? The first step is you write the first number down, the next step is you write the next number underneath it, and then you take the digits one by one, and then eventually you come to your total, and you follow these steps. And so, like when humans are doing this, yes, we're at a high level, we're following steps in order to do the math. But at the low level, our brain isn't doing that. But like when we program a computer, the computer at a low level is going to be doing all of these steps one at a time. And so like, this has been like the problem of computing ever since computing is that it's too slow, right? Because of this, you have to do one thing at a time. And so they found different tricks and whatnot to try to speed it up, like you um, like make the hardware run faster, and you run it on multiple processors, and you're able to get the computation to run faster. Um, um, one fascinating thing in thinking about the problem of driving a car, um, like one of the basic algorithms, one of the obvious algorithms in driving a car is the map. You have to have a map of the environment and be able to plan your pathway through it. Um, but then the other one, which is tricky, is the object avoidance. And um, because you don't want to crash and whatnot. But the thing with object avoidance is that it's almost the same algorithm as like a missile targeting system. So in a missile targeting system, the algorithm is to find the target and to steer towards it. But in a self-driving situation, the algorithm is to find the target and to drive away from it. And so it's a very it's like a similar realm of thinking. It's just instead of going towards the object, you go away from it. And so knowing that we have like these different missile systems and whatnot, it's like do they have a sophisticated enough algorithm to use in these self-driving systems? Um, and in looking in the history of it, it turns out the first uh, guided missiles that they made, they they use squirrels. They use squirrels to control the missile, and so they'd have they train these squirrels to look at a screen and then to control a joystick to move the missile to keep the target in the center of the screen. And because squirrels can think really fast, and and so that's how these guided missiles would work. And it kind of makes you wonder, okay, well maybe they haven't come up with anything better than that, and you just have to and so like they can't even share their missile guiding technology because it involves strapping the squirrels inside of missiles, and so you can really ethically do that on a large scale to billions of cars all around the world. But it's kind of an interesting thing because that's like because it's the same algorithm. If I can make a really good self-driving car, I can make a really good targeted missile as well. And so, like, is it a thing that we're ever going to actually get, or is this something that we can manage to work through? It's an interesting thing to think about. Um, okay, but if we think about how we